Hello everyone, our focus for this video is to be able to use the trigonometric ratios to find the missing angle of a given right angle triangle, right? And as you know that opposite over hypotenuse is associated with sine of an angle. You know that adjacent over hypotenuse is associated with cos of an angle, and opposite over adjacent is associated with tan of an angle. So here I have three triangles on the board, and we are asked to find angle M, angle Y, and angle X. Right? So I'm going to start with angle M first. Now here, this is a right angle triangle. So your first thing that you need to do is to label the triangle based on the information that you have been given. So you know that this is the 90 degree, opposite from the 90 degree is the hypotenuse. Right? So this length, which is 13, is the hypotenuse. We are given an angle. We know if we draw a line from this side going that direction, then this side that is directly in front of this angle is the opposite side. Which means that this side is alongside the angle, which means that this side is the adjacent. Now that we are clear on which side is the opposite, adjacent, and hypotenuse, then we can go ahead and decide which ratio would fit the information that we have. Now we have the adjacent length and we have the hypotenuse length. So adjacent over the hypotenuse is associated with cos of an angle, which means that we have to use this ratio here, which is cos of an angle. Now go ahead and you write your formula. So we know that cos x is equal to adjacent over the hypotenuse, right? Now what is x in this case? It's angle M. So we can go ahead and write cos of m degrees is equal to the adjacent length. What is the adjacent length? Which is 12. So this is 12 all over the hypotenuse length, and the hypotenuse length is 30. So this is 30. Now, how am I going to find the angle M degrees? Now, you have to use the inverse function. So I want to find the angle, and I want to get rid of this cos here. So I need to take cos inverse of both sides. So on this side, I'm left back with M degrees is equal to cos inverse, and you put a little -1. So you write cos and -1 for cos inverse. All of that in bracket, you put 12 over 13, which is 12 divided by 13. Now all you need to do to finish, which is m degrees is equal to, you just need to take a calculator and put that on a calculator. So on your calculator, you will note that for some calculator that cos inverse is in an orange color. So what you need to do is to press shift first. So you press shift, right? So you would press shift. So after you press shift, and then you press sign, and you get the sign inverse. Now it's a fraction, so I need to press the fraction bar. Then I will put 12 over 13. Then I close my bracket there. Then all you need to do is to press equal. Now when you press equal, the angle is about 67.38 degrees. Now we're just going to round off that angle to 1 decimal point. So because it is 68.38, the second decimal place is 8, which is greater than 5. That means we're going to increase the previous digit by 1 and forget about the rest. So our final answer is 67.4 degrees to 1 dp. And you just put that in a bracket to 1 dp. And that's how you would use the cos ratio So let's look at the second question. So here we have been given y degrees, we have been given 3 centimeter and 4 centimeter. So we're going to label our triangle. That's the approach. So we know that this is the hypotenuse, this side here. We know that according to this angle, which is y degrees, then this side is opposite. And according to this angle, then this side is adjacent. Now, we know that we don't have any information for the hypotenuse. We only have information for the opposite and the adjacent. We know that opposite over adjacent, that ratio is associated with the tangent. So we'd use this one. So we'd say that tan x is equal to the opposite over the adjacent. Now we know that x here is y degrees in this case, so tan y degrees is equal to the opposite. So opposite length is 3, so this is 3 all over the adjacent length, which is 4. Now we know that for us to find the angle, we need to take the inverse of the ratio. So y degrees is equal to tan inverse of 3 over 4. All we need to do is to place that on your calculator, and again you will make sure that you press shift and then you press tan to get the inverse. It's a fraction. You press the fraction bar, which is 3 over 4. Close your bracket, press equal, and our angle is 36.86, and we are going to round off to 1 decimal place, so it is 36.9. So our angle here is equal to 36.9 degrees. So that's how you find it. So let's just look at our last example here. Here we have been given x, angle x degrees, so we want to calculate the angle. Now, according to this angle, then where 4 is would be the opposite, and from the right angle here going this direction, we know that this is the hypotenuse. Alright, I don't need to label this side because I don't have any information for this side. So all I have is the opposite length and the hypotenuse length. Now when you look at the ratio, when you look at the all three ratios, the tangent ratio has to do with the opposite length and the adjacent length. We do not have the adjacent length, so this one is out. This ratio, which is the cos of an angle ratio, has to do with something with adjacent, so that one is out as well. So we're only left back with one choice, which is sine of an angle, and that's opposite over hypotenuse. So we write sine x is equal to opposite over the hypotenuse. Alright, what we're just going to fill out this formula with the information that we're given. So sine x is equal to opposite. What's the opposite length here? It is 4 meters, so this is 4 all over the hypotenuse length, and the hypotenuse length is 5, so this is 5. Again, to find what x is, which is x degrees in this case, we need to take the inverse of the function, which is sine inverse. So x degrees is equal to sine inverse of 4 over 5. Put that in bracket. All you need to do is to just put that on your calculator and you're finished. So you're going to take your calculator. What you're going to do, you're going to press shift and then press SIN, which is sine, and the sine inverse will come up. Select your fraction bar And the fraction that we have is 4 over 5. Close your bracket and then press equal. So our answer is 53.13. Now if you round off that to one decimal place, note that 53.13, 3 is less than 5, so you would just drop it off. So your final answer would be 53.1 degrees, right? And that is how you would use the sine, cosine, and tangent ratio to calculate a missing angle based on the information that is given. There is a nice way to remember all of these three ratios. Now you could use the first letter of each of these. So if you take S of sine, you would get S. You use O, which is O, and then you use the H, and then you use C, A, H, and then T, O, A, which is T, O, A. You put it together, you get SOHCAHTOA. So you can always use SOHCAHTOA to remember the trigonometric ratio. And what this is saying, S here means sine of an angle is equal to opposite over hypotenuse. This is saying cos of an angle is equal to adjacent over hypotenuse. And this one is saying that tan of an angle is equal to opposite over adjacent. And note that sine by itself means nothing, and cos by itself means nothing, and tan by itself means nothing. They are just operation. So if you say that sine, for example, sine here is equal to opposite over hypotenuse, that is incorrect. It has to be sine of some angle. So I just want you to get that clear. Sine by itself means nothing, cos by itself means nothing, tan by itself means nothing. Okay? Thank you for watching.